Saturday, June 13th, here in the garden. After watching the squirrels dig up, I think pretty much every, or almost every peanut, and hardly any having sprouted since these were planted 20 some days ago, it's become clear that if we want peanuts, we're gonna have to redo this. So just a few have managed to survive. And maybe this time, let's learn from our mistakes. So as soon as the peanuts go in the ground, we're going to have to put the chicken wire on top of them to prevent squirrels from digging them all up, because it's just too interesting for them. Second thing that needs to happen is peanuts need really consistent watering, and we are just not great at doing that. So I hatched a scheme. The challenge is taking advantage of the water in these rain barrels and getting it over to the peanuts into an irrigation system. So a couple years ago, we set up an irrigation system in the front wildflower bed, and I got all the parts from a company called Drip Depot, and they had phenomenal customer service that time. So for this project, I sketched out a rough map of what the problem is. Rain barrels. There's an empty conduit here that goes under the ground to the greenhouse, and then that's where the peanuts are. And I made a list of the parts we had, and a wonderful representative named Michael was pretty much like, no problem, you can absolutely do this, and here's what we're gonna do. So he walked me through each step of the process. We need to pump the water up and out of the rain barrels, because this 2 feet of elevation won't generate enough pressure to get the water 50 feet away to the greenhouse, and it definitely won't generate enough pressure to get any flow through the drip irrigation. So step 1 is establish a pump. Step 2 is run PEX through this empty conduit that goes to the greenhouse. That was harder to do than I thought it was going to be. Matt used brute force on that. And here's the PEX coming out of that conduit. So from here, I'll obviously trim the PEX. It'll go back into a garden hose that'll snake through the greenhouse and come into the bed here to make kind of like an irrigation manifold. So here's what Michael helped me design. Yo, Rose, you're ruining my demo. All right, the dog's shadows are going to be all over the place in this. So I'm going to start. The water is in the rain barrel, and that has to come up and out somehow. So this is a pump with an auto off sensor. So if the rain barrel is dry, it won't just keep running and burn itself out. Next, we have to convert the output of this, which is 1.5 inch something or other, into garden hose. So just, Rose, stop breathing so heavy. Convert it into garden hose, pretend there's a garden hose here, into this fixture. Wow, my helpers here are not really getting out of the way. This is a, what is it called? A vacuum relief valve. This has to go at the very top of the barrel. So hose comes in this way, hose goes out that way to continue the rest of the setup. This is a little vacuum relief, because when you're pumping something from some height and you're having it travel and terminate lower than the barrel, for instance, like the garage is, after the pump turns off, there's a chance you can generate a siphon that even when the pump is running, the siphon's just pulling water out of the rain barrels. So we didn't want that, so you need the vacuum relief valve. So this has to be at the very top of the barrel. This hose will go down, and this fitting converts it from garden hose to 1/2-inch PEX. The PEX is already under the ground. Same fitting on this side, converting from PEX to garden hose. Make pretend there's hose here. And then this is a filter, a pressure regulator, and this is the fittings to be able to use the drip irrigation tape. So this I have a history of not getting the right fittings because I don't make a map like this. The amount of nonsense I sent Michael was really impressive, and he was able to confirm that I did have the right fittings and plan and all of it. So now we just have to assemble it. It's like 9 o'clock. It's probably not even 9 in the morning, and it's already a gazillion degrees. So we'll see how much steam I have for Bonnie. We'll see how much steam I have for the project as the heat of the day goes on. This is the fastest I've ever done a project. We actually started at 9:30 and now it's 11 and we're ready to test it. I did an initial test of just this apparatus of the pump in there up to the Y with the pressure or the vacuum relief and down into the PEX transition. And now that comes out the other side and into the irrigation manifold. So let's give it a test and turn it on right now by just plugging the pump into, oh gosh, sorry gang. Plug the pump into the cord. So I just heard the vacuum relief hit, no leaks to get to the PEX. Not really a gorgeous solution here, but whatever, it works. PEX comes out, a 90. Usually in the summer, I keep this door shut and the other door open, so that's what that is. Over to here, a 90 on the PEX into the filter and the pressure regulator. And I hear there's a couple leaks. That's okay. This is reused irrigation tape, so there's going to be a couple leaks. All right, try to not get water all over the phone here. So is that able to be seen, the dripping? Yeah, there we go. That's perfect. So yeah, there's a couple obvious little holes to fill. Is this irrigation tape was it was used out in the wildflower beds, so, and kind of crumpled up in storage, but I am pretty dang pleased. So now that the irrigation is done and I got most of the weeds out of this patch, later today we'll come in and plant the peanuts a little more intentionally and yeah, put those covers back on. But oh wow, this is just super. It's dripping perfect. Great. This time we have Tennessee Valencia peanuts from Urban Farmer. Soaked them overnight. I'm just tossing them in some of that inoculant. Yep, and I have like 20 minutes to put these in the ground before we have to go to a pool party. So wish me luck. So trying to be a little more intentional than that super casual planting last time. I used a dibble, which is like a vampire steak on a tee. There's depth readings on this, but who can be bothered? So I felt along the bottom of this drip tape for each of the emitters. So I put a hole with the dibble under each emitter. And now I'm going through and putting 2 inoculant coated peanuts per spot. And then we'll cover that up. And then put the chicken wire bow over top. Here it is. in all its glory. It's dripping. It's protected by chicken wire. Oh gosh, boy is that not able to focus on where the drip's coming out. But yeah, I hope you believe me that this is gonna be awesome. So irrigation is all done. And now it's time to do a little math to figure out how long it needs to run to get the amount of water that the peanuts are gonna need. Here we are doing math homework for the irrigation. So here's the not to scale drawing of 11 feet by 12 feet of the total patch. And then inside there's the irrigation manifold, and it comes across 5 times. This length is 9 feet and this length is 10 feet. So the first thing to figure out is what volume of water is going to be sufficient to cover this area per week. So peanuts need 1 to 2 inches of rain per week. Okay, so to get to volume, you have to multiply length by width by depth. So the volume is equal to 11 feet multiplied by 12 feet multiplied by the depth. We'll use 1 inch for all the math. So 1 inch is 1/12 of a foot, and this works out to 11 cubic feet. Because the emitter math is all in gallons, we have to convert cubic feet into gallons. 11 cubic, oops, that's not division yet. 11 cubic feet times every 0.134 cubic feet is 1 gallon. So this works out to 11 times, divided by 0.134 goes, we'll call that 82 gallons. And that's how much gallons we need per week. All right, great. Now we have to figure out how many emitters we have and how much they're dripping per hour. So the length here is, there's 5 lengths of 10 feet each, plus 2 lengths of 9 feet each, which is 68 feet. There's the drip tape I bought. It's the spacing is 6-inch emitters at 0.37 gallons per hour. So if we've got 68 feet total, that works out to 36 emitters. Each emitter drips at a rate of 0.37 gallons per hour. So 136 by 0.37. All right. So every hour the system can send 50 gallons, 50.3 gallons through the openings. Okay, the last piece of math. If we need to get 82 gallons each week from the system that drips at 50.3 gallons per hour, so 50.3 gallons per hour. Do the math like that, so your gallons cross out. So 82 divided by 50.3, 1.63 hours, which is equal to, we'll call that 98 minutes. So this whole system has to run 98 minutes per week. If I'm running it every day, you divide that by 7. Oh my gosh, 98 divided, is that right? 98 divided by 7 is 14? Oh my gosh, what is happening? How? Oh. 98 divided by 7. 14, okay, 14 mins per day. Great. So while the peanuts are in this germination stage, we need to be able to run the irrigation system for 14 minutes per day. I have a fancy timer that lets you do that. Yeah, so now this is set up for worry-free irrigation.